Hi, I'm Adam.
Hi, I'm Jenny.
We're back for another podcast, this time about space and spatial relations.
Right, what are we going to talk about then?
Well, let's go to Sigma first, and why don't we look up the class spatial relation?
Okay. Well, while you do that, maybe we want to explain and remind our audience about the use of capital letter in Sigma.
Yeah, so Sigma's, or rather SUMO, is a programming language, and so like any programming language, it's very specific about spelling and capitalization. It uses, by convention, what programmers tend to call camel case, because it looks kind of like the humps of a camel when you have
Okay.
words that flow together. So word boundaries are indicated with a capital letter, so hence
Right.
spatial with a capital S, relation with a capital R. Okay, and also a reminder for using Sigma, we type SUMO terms in the KB relation field. If we want to have a word from English, then we can type it in the English word field and we'll get a search on WordNet and its word senses.
Right.
Okay, so let's take a look at spatial relation. All right, so class of relations that are spatial, as expected. Get a list of a lot of instances of spatial
Uh-huh.
relation. Okay, a lot to choose from here. So I'd encourage people to spend some time browsing around and see what's here. If you're going to be working on a project that has a need for talking about space, and most practical or common sense projects will at some point, good idea to familiarize yourself with a few of these things.
So what is going to be the things that we're going to work on?
Well, why don't we try to go through a couple of examples of English sentences that have a spatial concept embedded in them and see if we can try to represent them.
Okay, I've got one for you here.
Okay?
Mexico, the country of Mexico, it's south of the United States.
Okay, great. So let's try to start with collecting some terms. So let's just make sure that we have Mexico. Okay, great. That is the right way to spell it. Oh, in the United States, so it'll give us a shortcut. I don't have to type it. Okay, great. United States is in there. And south.
How are we
Okay.
going to represent it?
Yeah. So let's go back to spatial relation and look at what might give us what we need. So
Orientation?
orientation, that looks pretty likely, and it happens to be the right answer in this case.
Right, but then we have to look at the arguments.
Yeah, and this is a relationship that's a little unusual. It's a ternary relation.
Taking three arguments?
Three arguments, right, not the usual two that's far more common. Another example of why having an expressive language like SUO-KIF that can handle arbitrary numbers of arguments is really important, because the notion of orientation is just fundamentally a relationship amongst three things. Hard to reduce it there, and silly if you had to. So let's see. So we've got a relationship with two objects and then an attribute that holds between them.
Position.
Yeah, positional attribute. All right, so let's see what positional attributes we have. It looks like we've got a whole bunch for expressing things that are, in some sense, a little vague or approximate.
Okay.
Right? I mean, we want SUMO has a lot of facilities for that allow us to say just exactly what we mean, no more, no less. Kind of like
Right.
what we would in an English conversation. We talk about something being south of or next to, and we don't
Okay.
have to give precise geometric coordinates to say that like we would in a geographic information system. So SUMO gives us that same ability that natural human language has.
Okay.
So let's see, in this case, we want to look at directional attributes. Directional attributes are the attributes that concern compass directions.
Uh-huh.
So you can see all the ones we'd expect, including south.
But look at that, it's an instant.
It is an instance, yes. South is an instance of the class of all directional attributes. Okay?
Right.
Attributes are instances.
Right.
So let's go back to orientation. Yeah, and you see that orientation takes an instance of a positional attribute. The domain definition here, the argument type definition, means that we need an instance of positional attribute, an instance of object, an instance of object.
So we got everything.
We've got everything we need, so let's go code it up. Okay, so got our editor open, or whoops, need to open a new document. There we go. So orientation, and oh, we should check on the order of the arguments.
Okay. Which go first?
Yeah. So
We have an example here.
yeah, very convenient. So the documentation is telling us that object 1 in our case is the thing that's going to be north of object 2.
Okay.
Okay. So in our case, we're talking about
Object 1 is Mexico.
Object 1 is Mexico because we're going to use the south relation. Of course, we could reverse it and say United States is north of Mexico, but in this case, we're going to say Mexico is south of the U.S.
Okay.
All right, so let's type it in. Mexico, United States.
No, south.
Oh, south, thank you. Great. Okay,
That's easy.
yep,
Let's do a few more.
okay.
How about Adam lives in California?
Okay. So let's see. So let's do the same kind of inventory that we need to. So let's check on California. That should be an easy one. Okay, great. SUMO has California by that name that we expect. And lives in. Okay. So I happen to know that the term we want is home. That reflects one's permanent residence.
Okay.
Okay, so we have a human has a permanent residence. So let's see what a permanent residence is.
That's what happened with looking up into Sigma. It gets you to look up into one of the words and find out the expression, the meaning, and the arguments.
Right, right. It's like any other programming language library, especially when you're a beginner. You have to spend a lot of time poking around, learning the library. Now that can seem like a big imposition, but the alternative is to try to code everything up from scratch, and that just takes a lot more time, and it's a lot more error-prone than reusing something that's already been vetted over many years.
Exactly.
That's why all programmers use libraries and don't write everything from scratch. So the same is true in this programming language for representing knowledge about the world. Okay, so let's take a look at permanent residence. Okay, permanent residence is a kind of residence. A residence is a kind of stationary artifact. Okay, and a stationary artifact has a fixed spatial location. And there are lots of different ones, like building would be a good one. Okay, 'cause most people live in buildings. All right, so that presents an interesting issue, right? Now we've said that home requires a building, but then we have to say that that building is in California. We can't just say directly the person lives in California, because California isn't a permanent residence.
No.
It's a geographic location.
Right. So what are we going to do?
All right, so that tells us we need, let's say there exists some home.
We need an instant, don't we?
Yeah, we need an instance H, let's call it a building.
Okay.
And let's say home of Adam is
H.
H. And then we want to say that that building is located in California.
It's located a term in SUMO.
Let's check. Just so happens that it is.
Right, that's handy.
Okay, located, object 1 is located, partly located at object 2. Okay, so let's go back and state that. Located, H, California. Oops, there we go.
Brackets are important.
Brackets are very important if you use a text editor that has parentheses balancing. That can be handy. Emacs does that. Many others do. Otherwise, you spend a lot of time counting parentheses, and that can be kind of error-prone.
But in this case, I do have a problem. If I start with living, and I would try to use living in SUMO terms and start it as a process, how would I end up being doing the thing that you're doing in terms of using spatial relationship?
Well, it all depends on what you're trying to represent. If you wanted
Okay.
to represent the fact that I am living in California and I'm performing this action, that's kind of what you want to represent, well then yes, you would use a process. But if you want to represent the fact, the situation, not the process, then this is the way to do it. And of course,
Okay.
English is like that. You really have some ambiguity. And when you say, I live in California, it really does mean a couple of things. It means I'm living in California. There's a process going on. I'm going about my daily activities of living and surviving.
Yeah.
But it also means I have a particular spatial location, and that's
Right.
just a fact about the world, a statement that's not talking about the process of living. It's talking about a relationship between my body and the rest of the world.
Okay.
Okay. All right, should we go on to one more example?
You still want to do one more?
Oh yeah.
Okay, just one more. How about a more difficult one? The arrow has pierced the apple.
Okay, so same idea here. We could talk about William Tell shooting his proverbial arrow through the apple on his son's head, but here we're focusing in this podcast on spatial relations. So we just want to talk about the relationship,
Okay.
the spatial relationship between the apple and the arrow.
But how are we going to do it?
Well, let's start with our nouns because those will be simpler. So
Look up at sigma.
yeah, so let's look up, see if we have apple. Okay, we do, good. And arrow. So we don't have arrow at least, but we do have arrow projectile. That's actually what we want. It's spelled a little differently. That's why we have this kind of alphabetic list, so that if you spell something wrong, you get a list that hopefully you can poke around and find what you actually need.
Right.
Okay, arrow projectile, great. That is what we need. Okay, and then the question is what kind of spatial relationship to use. So let's go back to spatial relation
Yeah.
and see what's available to us. Okay, so height, path, between, connects, contains. Oh, those don't look right. Traverses.
Okay.
That one looks likely. And in fact, we've got one that's even better. Penetrates is a kind of traversing, but it's even more specific that we can look
Right.
at. Right. So it's spatially connected, it's touching, and it's along at least one whole dimension. So,
Right.
it's passing through the diameter of the apple, not just some little portion of it.
Very
Right.
precise.
Yeah, we have a whole set of axioms, spatial axioms that traverses is either crossing or penetrating, etc. That kind
Uh-huh.
of define precisely, we hope, what all of these things mean. All right, so
Let's
now
start.
we've got,
Coding.
yeah, let's start some coding. All right, so we're going to need to create some instances
Yes.
of an arrow
Yes.
and an apple.
Yes.
Okay, get our quantifier list going. We're going to have several clauses, so we need a conjunction. So let's say that we have an instance of an arrow projectile, instance of an apple, and we found that penetrates what we wanted.
Which one into which?
Let's take a look at penetrates. Penetrates object 1, object 2. So object 1 is connected to object 2. Right? Same as traverses. It penetrates. The peninsula penetrates the water. Here are some examples. You can look at the way it's used in other axioms also. The cape penetrates the water region. The
Okay.
inlet penetrates the land. That looks
Yeah.
just right to me.
And Adam,
Okay?
you do have a rule of thumb in terms of putting the arguments together.
Yeah, so the rule of thumb is that the smaller thing usually goes first. So, for example, in subrelation here, you see that the more specific thing penetrates before the more general thing. The same for subclass. The subclass goes first. In the part relationship, the spatial part goes first, and then the whole goes second. All right? So now we know that the arrow penetrates the apple. We'll close up a couple of our parentheses, and we're done.
Well done.
Yeah, Anything else you want to add, or I think we're all set for now?
I think I have quite enough today.
Okay, great. We hope this has been helpful, and thanks for listening.
Bye.
Bye.